Hello all, Lee from Fry's Garage here. So, interesting one, and I do little videos on these ones because these are interesting and there's a lot for me to learn and you guys, and I can pass it on, alright? So any workshop likes something where you can take a shortcut, and I know this, I've heard this before, and it saves a lot of time for yourself and the customer, okay? It's a win-win. So, I have a late model, 2018 Volkswagen Passat, beautiful R-Line vehicle. Now, customer said that the battery went flat, so they changed the battery, and lo and behold, in the morning, the battery was dead flat. So I went around there and it measured 2.2 volts. Very expensive battery in these, closer to sort of, you know, 450, 500 bucks. Now, anyway, so I pulled it out. I managed to save it on the smart charger. So anyway, starts up, but we have all of these fault lights, and we have a stereo unit or multifunction center that's not communicating, so that's going to be a CAN line issue. So this thing's full of gremlins. Now, apart from the battery going flat, so obviously we got a lot of parasitic voltage or current draw overnight. It's dropping the voltage right down. I can't turn this engine off. Right, so the normal stop start. Now if I push it, all right, that's what we get. All right, oh, it stopped. All right, well there you go. I've tried that 4 times and it didn't stop. So we are very, very lucky, because I think I was going to be disconnecting batteries and shutting it down somehow. Now I've done a system scan on this thing, and it is absolutely full, chockers, and I mean chockers, of codes. Okay. So, in the engine side alone, okay, we've got 16 fault codes. So let's just see what they are. I've just done a full scan right through the car, and I'm going to print it because I can. It's good to show the customer what you find, and it gives you a good way to explain your theories, and you've got the evidence. It's very important. All right, so we have all sorts of stuff. There's a lot of short to positive, so B plus is battery, short to, so that's like a dead short. Voltage terminal implausible. I see a lot of short to grounds and short to powers. This is really bizarre. Interesting. Starter circuit, or starter relay circuit low. That might have been when the, yeah, so when the battery was right down and they went to start it, that's when that would have come up. Lost communication with restraint control module, so the SRS module. Lost communication with the power steering control module. Oh joy, this is fun. So if we go back, so transmission, we got 1 code, we've got 13 fault codes in the central electric, so that's basically the body control module for the car. Yeah, look at them. Gosh, got 7 in the data bus OBD interface. We got 9 in the lane change assist module. So this is telling me we have a short, potentially in the CAN line system, potentially, and it's knocking them all out. So front sensor for driver's assistance system, 10 fault codes. All right. Anyway, look, 80% of those might have come about when the battery went below threshold lowest voltage. Okay, I've seen this a million times. So that's what we call ghost codes. They're not issues. You're chasing your tail. All right, so what I suggest is you get the system voltage to where it should be, charge the battery, go back in, do a report. It is fundamental to have a report, because as soon as you clear all these codes, you have nothing left. Okay, so I'm going to clear all the codes. I'm going to check the alternator. I'm going to check for short to ground on the main system, and then we'll go back in and see what fault codes come back up with a charged battery. All right, so let's come back after that. See you in a minute. All right, so I'm back. I found the problem. I'm going to run it through with you guys step by step, and give you a couple of key pointers that I think is like the most important key pointers when it comes to you guys diagnosing mechanics, and mechanics now having to be electrical and electronic savvy. All right, it's a must. I'm sorry, but the old days are gone. You need to know how both integrate, okay? You can't just call the electrician to do these jobs because you know what? There's hardly any around anymore, okay? So we need to upskill. That's how it is, guys, all right? And look, it's rewarding. I enjoy it. Like this one here, I am tickle pink, all right? I fixed it. I've gone through the right process, which I've learned over the years, and I've done it. So I'm gonna have a very happy customer. It could be one of those jobs where we change computers, we change looms, and all the stuff that you hear about all the time. We've got to stop chasing our tails. If we start chasing our tails, we've got to stop, think, and move on from there, all right? So I'm gonna show you how many codes are in this car. I've printed it because I've got the workshop printer, all right? Technology, must have. All right, so I'll turn the camera around. All right, so engine control module, 16 active fault codes. Now, most of them are power related, okay? Systems, voltage low, short to ground, a ton of communication errors. Remembering CAN lines, communication area network. All these computers talk to each other via the CAN line most of the time now, okay? There's some few variables, but we'll keep it as what it is, as a common, all right? Now, going over, electronic, central electric, body control module for the Volkswagen, basically. Look at this, data bus missing message, communication, okay? Voltage issues, communication. What else we've got? Airbag, so SRS, okay? Same thing, data bus, voltage, instrument cluster, data bus, voltages, shorts, opens, not enough volts, blah, blah, blah. All right, steering column, seat adjustment. Every module in this car, 70% of them weren't communicating properly, okay? So when you do your topology, when you connect your scan tool and you do your topology, and what I mean by that is the scan tool can see what that vehicle, whether it's earth moving, civil stuff, cars, trucks, buses, aeroplanes, boats now, okay? You can see what computers that particular asset has, right? And generally you can see that there will be a module that's got a failure. It's not communicating with it, okay? So that's what we call the black duck, all right? The black duck is usually the issue. So whether it's an internal fault or whether it's a voltage problem or whether it is, like a CAN line, a communication, all right? So look, when I say CAN line, I perceived it since CAN lines first came out years ago, because I was lucky to do the transition from full electrical mechanical to the CAN lines and blah, blah, blah. So consider a CAN line a train track. There's a train track between houses. Those houses do different things, all right? And there's different gnomes in the houses, all right? Sounds stupid, but remember it, it'll work for you, and you'll think about me later in the years, all right? Now those gnomes do different tasks, okay? Now, if the train rolls off the track, well, the gnomes and whatever they're carrying can't get between the houses, can they? Right? So that's what we call a communication breakdown, error, disconnection, whatever. So the gnomes in the other house, they can't do anything, right? It's not going to operate. Whatever they're doing, it's not going to operate, all right? And there's a problem between the houses because the trains come off the track, all right? And everyone's worried. It's a warning. It's a sign. Problems, right? That's how I think about it, okay? So train track between houses, where there's 3 houses. So let's go to a basic older truck, all right? Let's pick a Hino, Isuzu, right? Originally, engine control module, ECM. Transmission, so I had a Allison, transmission control module, TCM, all right? And then ABS, all right? Assisted braking system, okay? That's as basic as it used to be at the beginning. But now chuck in body control modules, aircon modules, left door, right door, EBS, it goes on, trailer modules, okay? They're little houses with gnomes in them, right? They got a job to do, okay? So if the train tracks between those houses aren't working, well, things aren't gonna work and no one's communicating. So back to the Passat, okay? remembering that this had a battery that would discharge basically overnight. First time the alarm went off at night, okay, 3 o'clock in the morning, I think they said. That's horrible, all right? So not favourable. But what happened is the battery voltage got so low that it triggered everything, all low voltage threshold points in every control module, and obviously the alarm system, okay? The first thing I did, apart from plug in to look at all the fault codes and see what the common issue was. So the common issue was what? Communication fault, CAN line, voltages. Well, if you have a voltage issue, you've probably got a CAN line issue. If you've got a CAN line issue, you might have a voltage issue to something else, all right? But we can't chase our tails. We need to see what the potential causes can be without spending all bloody week on it, all right? So the first thing that I do, knowing that this battery went flat overnight, okay? I put my amp meter on there, okay, because I've got a clamp meter, all right? So I'm going to show you this because everyone needs to know how to do it. The people that don't know, right, this is for you. All the other people laughing at me, yeah, we know all this shit. You know what? You're watching the wrong video, all right? Go watch something else, all right? But this is for the people that are learning, apprentices, people at home, and it's great information because it will save you a ton of money and a ton of wasted time. It will save it. So I wanted to put my amp meter on there. So with the ignition off, door shut, car in sleep mode, I wanted to see what the current draw was, because for a battery to go flat overnight, we have quite a large, what we call parasitic, I said it before, parasitic current drain. So parasite means a leech, something that's drawing, sucking your blood, taking something from you, right, when you don't want to be taken it, well, you don't want it to be taken, all right? People at work borrowing money for durries, smoko, right? Call them the leeches, the parasites, right? Whatever, it's all good. We're here for each other. But you know what I'm saying, all right? That it's taking from you when you don't really want it. All right, so I'll put my clamp meter on there. Car is in sleep mode. So we're gonna see what the current drain is in sleep mode. Before we do that, quickly, older cars, basic cars, 0.2 to 0.4 amps maximum per hour of current drain, and that's with clocks and basic computer module, all right? So let's say just the engine ECU and possibly ABS. Now, all these funkier cars, like this Volkswagen, all right, it has a lot of modules. It has a clock, it's electronic. There's a lot of standby features in these modules, okay? So if you went away for 2 or 3, 4 weeks, that battery will be quite low because standby voltage has been used, okay? So there's parasitic voltage, but it is normal, okay? Naturally, if you want to go away, you disconnect your battery, all right? So being quite a big battery, the one that's in here is a 90 amp. That's huge for a small car, but that's why they do it, okay? If you see big batteries in cars, from factory, it's because the current draw is quite big, whether it's in standby mode or when it's in running, okay? All right, so I'll turn the camera around. Let's have a look. I'll show you the basics and how I use my clamp meter and how we see what this current draw is, what's good, what's bad, and then I'm gonna show you what I found with this. I didn't record what I found as such because I cleaned it, put it back together, but however, I took photos, so we'll add them in the video. All right, so I'll turn. Okay, clamp meter. This cost me $1,100, so it's got the normal, you know, the leads for doing your basic stuff, but through here, we put it over the cable and it measures current. Okay, so we'll turn it on. God, the thing better turn on because I know I had flat batteries before. Oh, there we go. Okay, so we'll put it on there. We'll let it settle. All right. So I actually think, yeah, I've got a window open and a door open, so that's what that is. So that's that. Oh no, for some reason it's not clearing. What's going on here? Let's reset that. All right, when it sees some current there, that should zero out. So Alrighty. Now, I'm going to turn the ignition on, and I'm going to come back and see what the current draw is with the ignition on. Let's have a look. Now, remembering, with the ignition on, you are waking up all the computers. Everything is turning on. It's what we call switch power. All right? So we'll just go ignition. Ignition on. So it wakes up the modules. You've got lots of lights going on. The open door light's on. Now it's shut. Now let's see what current we're drawing there. It's going to be quite large. Look at that. 22.7 amps. Okay? Now, let's think about this. That is a 90 amp battery. Divide that by 22.3, or 22.7, so it's roughly, yeah, let's round it off to 20, okay? That's what, 4 hours, 4 and a bit hours? 4 and a bit hours, that will be pretty close to flat, all right? So that's a long time to leave the car on. Now, let's turn the fan on. So your vent fan, let's see what happens. Let's see how much it goes up. What I'll do is I'll put it on full, just so we can see what the maximum current draw is. So let's turn that. All right, we're on full, okay? There's little bells and whistles and alarms. God, it does my head in. Tell you what, I won't be buying another new car, I'm over it. Anyway, it's all good. All right, 27, 28, all right? So 6 amps just for the fan at high, which I can tell you what, that's actually quite good, okay? But now, let's say we walked out from the workshop, I had a phone call or something happened at the front yard, came back 3 hours later, that's nearly 30 amps draw. We got a 90 amp battery, well guess what? Around the 3.5 hours, maybe a bit more. Look, it's 90 amp rated, but it might be good for sort of a little bit more. It might be okay for 4 hours, but I'm trying to give you a bit of a picture of what's going on. All right, let's start it up and see what happens. Now I can't show you the amp draw when it's cranking because my arms aren't long enough. So we'll start her up. Oh, God. So, foot on the brake, on the button. Okay, she is running. Now it's got auto lights. I'm going to turn the auto lights off, so there is no lights whatsoever. Alright, what do we got? There you go, 41 amps current draw, okay, around there. So we have a fan running, we have all active modules running, we have a fuel pump, we have all the electronics for the engine running. Alright, so we've got the O2 sensor, they draw some power, the injector driver, there's quite a lot of current draw there. We've got a throttle control, alright, we got modules everywhere, they are all running, okay. So the engine started, okay, let's see for after a couple of minutes where it settles to. I'm assuming it's still going to be around the 29 to 30. Alright. Let's see. Okay, so we're coming down. Look, I'm not going to stand here all day, but you can kind of see what's happening, alright? We've got a current draw. It's not huge, but it's not small, but it's running the car. Everything that needs to be running is pulling, alright? It's pulling the voltage, or the current, shall I say. So now what I'm going to do is I'm going to turn this off, and I'm going to explain what I found with all the issues. Just reach in. Alright, that's off. Now, actually quickly, I'll show you what happens with the amps. So it's still hanging at 10, but you can hear the throttle position sensor calibrating and shutting down. Everything will go into a shutdown, okay? Once it's all done, that current draw should pretty much, 90% of it will be gone. Here we go. So we've had something stop, and I think it sounds like the throttle actuator. Alright, I can hear the ABS module, so that's doing a check. You've got to remember, guys and girls, when you turn a machine off these days, that's got onboard modules, it does what's called a check over, all right, or a system check on power down. So when you turn the ignition on the next time, which is the next ignition cycle, it will bring up potential fault codes if it finds any problem, all right. So I can hear some buzzing. I don't know if you can hear that. Right, there's a lot going on, okay. It's starting to climb down, so certain features are turning off one by one. And while it keeps going, what I'll do is I'll explain, okay. So I had my amp meter connected as is originally with all the fault codes. Engine was off, ignition was off, car was in standby, there was no doors open, no you know, no lights on, no interior lights turned on. It was in sleep mode, okay. Now this meter, right, was reading 9.5 amps, okay. Sorry, 19.5 amps. That's big, all right. Remembering this was all asleep, okay. 19.5, or just under 19.5 amps, okay. So I knew, whoa, we do have, and the camera around, I'm talking to myself. So there was some parasitic voltage there, current drain, all right, so quite a lot. So I put my ear to things. So if you've got, you know, from 15 onwards amp draw, that's either a driver motor, a relay, another one that people forget, heated seats, okay? So I did have a couple of cars in the past where the heated seat relay would jam on. So it wasn't supplying the seat as such, but the relays are quite heavy duty and the coil was latching all the time. It was hanging, so it was drawing that current all the time to keep latched, okay? So there's like a secondary relay, then that power goes via fuse to the heated seat element. Anyway, but that was enough to drain the battery within a couple of days. So yeah, look, anything over 0.5 amps, even in one of these cars, right? Something's going on. There's something going on there, okay? Look, if you got to 1 amp, I wouldn't be too concerned, but you just got to remember the longer you wait, the flatter that battery's going to get. And sometimes it's like finding a needle in a bloody haystack, okay? So what we're going to do is we've got to eliminate each circuit. So we can pull a fuse on the light circuit, pull a fuse on all circuits until you notice that that amp meter, or if you've got an inline multimeter, and I'll show you how we connect that, until that reading goes down considerably, okay? Then you know what your problematic circuit is. So anyway, so back to this one. So our meter connected, I'll turn it around. So connected, and I thought before I put my oscilloscope on and all my test equipment, I'll just quickly put my ear around, all right? So the car had been sitting for 10 minutes. I let it all power down and just sit there for 10 minutes. So I put my ear, I had it on the hoist actually, I was underneath. I could hear a bit of a buzzing noise. I'm around here, I'm like, oh, that's weird. Put it down on the ground, had a listen all around here, like my head really low, and I could hear this really slow buzzing noise. Yeah, it was an electrical buzz. I'm like, well, you know what? I'm gonna quickly put my oscilloscope on and just onto the CAN lines and just see if there's any interruption or any noise on there, and there was. It was quite spiky. All right, I'm not going to go into it. CAN lines, Google it. There's a million videos. I don't need to do another one. Okay, but there was an interference in the CAN network, and it was caused by this noise. All right, it was a no-brainer. So the problem was, where was the noise? Anyway, so I put the car back on the floor, and I pull my ear along the front of the engine here and closer down to here, around the trans, and lo and behold, I could hear this buzzing from down on top of the trans area. And I could follow, I don't know if you can see it, no you can't, but there's a trans loom, all right? There's a plug, big round plug. And I put my hand on it because it goes to the transmission control module, basically on top of the trans. And I could feel that humming. It was very slight, but I still got sensitive fingers. I could feel it. Anyway, I thought I'd do the most logical thing. I just disconnected the plug of the transmission control module after doing other things. Okay, I won't get into that. That amp meter reading went boom down, went to like 0.5 amps. I put it back in again, bang, up again. So, okay. So anyway, so I pulled the plug out, had a look. I'll send you the photos with the video. It was half full. Actually, no, I'm going to say half full of water. There was quite a few drops of water in there, and the water was enough because the plug is on an angle, okay? So the water sat flat. And what it had done, it had shorted out between CAN high pin and a positive and negative for the TCM. So what was happening is with the ignition on and the main power, right, because actually it was 15 and 50, right, or 30 shall I say, the power was spiking through the CAN line, interrupting all the CAN network, and at the same time it was holding on because there was actually 4 pins sort of like tacked together or joined with the moisture, and one of them would have been a control valve or solenoid for the trans. And that makes sense because it's enough current draw as to what we were getting originally, so like that 15 to 19 amp current draw. So anyway, so I pulled the plug, good old spray, so electric spray, blew it out with air, and guess what? Connected it all, bonza, all right, as quick as that. All right, so you've got to do your fundamentals. And guys and girls, if you do not have one of these amp meters, you need to get one, okay, because it will help you on testing alternators. To what I do is I clamp this on the positive cable of starter motors. So if a customer says, oh, my Caterpillar machine or dump, whatever it is slow to start, or I'll keep doing batteries, I'll connect this, I'll get someone to start the engine, and I'll watch the total current drain at that cranking speed, all right? Now, if it shows it is drawing a lot of current, we either have an engine that's tight to turn or whatever, or we have a gummed up or a sooted up carbon starter motor, okay? This is gold, okay? Look, they're not cheap. Don't buy a cheap one. Please do not buy a cheap one. And get the clamp meter because it's an investment. Now, if you do not have the clamp meter, so forget that top exists, you have a standard multimeter. You will still go to amps, okay? You'll have your lines. Some you've got to put into an amp hole, but this is automatic, so that's fine. And what you'll do, you'll disconnect the positive cable to the battery, okay? You'll connect either positive or negative cable from your meter, it doesn't matter, okay, to the cable. So let's say the cable's hanging out here. So you connect one lead from here to the cable, and then you connect the other lead, whoops, to the battery terminal, because remember, this terminal is off. So basically, this is in line. So then your multimeter will be able to sense the current draw, okay? But you need to remember, if you do that using those small lines, you can't start the engine, you can't run it, all right? It will not even start, because I can tell you now, with just this in line of there's 2 little cables joining the battery and the cable here, the battery terminal and the cable, it won't start, all right? There's not enough current to give. And that's why I say, get this, because I can get up to 300 amps here, I think it is. Oh, sorry, 1,000, there you go. 1,000 amps, okay? And I've used this for the big V16 cats and all sorts of stuff, down to the little Passat TSI. All right, good investment. So there you go, guys. So what I did is, I cleaned that out, put it back on. I cleaned all the codes. It starts every time, it stops every time, there's no faults, everything works, all because of a little bit of moisture in that plug, disturbing 1, CAN line, 2, voltage, right? Computers, the gnomes were seeing things, but the train on the tracks to the gnomes in the houses, right? Well, there was a bit of electricity, a bit of jittering going on there, so the gnomes driving the train, they were a bit scattered, all right? So, yeah, anyway, you can see my point, all right? So that's it. So all I'm going to go into, parasitic current draw, all right? I can ring the customer now and say, hey, I fixed it. I haven't changed the computer. I haven't changed the harness. I haven't done the gauge cluster. I haven't changed the CAN module. All right, I've gone back to basics. Check it, go with your gut feeling, and please make sure you download all fault codes, and you can see, all right, you'll be able to see the commons, right? So whether it's CAN line, whether it's a short to ground, and if no fuses have blown, you don't have shorts, all right? It's just going to be a small voltage sensing that a module's seen, and in this case, there was water sitting between the positive and the negative of both ignition, which is switch power, and battery, which is unswitched power. So it didn't like it, and it threw a fault code for it. So it got us closer. So anyway, hope I haven't confused you. That's how I logically do it. Get yourself an amp meter, because I use it for everything from injectors to, I can't recommend it anymore, I really can't, all right? And it'll make you grow in here a lot, and you'll learn a lot by yourself. And then there's Google and all the other stuff to help you learn. There's that much. You can really do whatever you like, all right, guys? So keep learning, enjoy. I'm going to shut up now, all right? You're probably sick of hearing me. But that's in a nutshell. When I ring the customer now, I feel good. They're going to feel good. I can send a bill, and I know she's done, all right? Take care, all. I'll